Hey there, Coach Travis here, and I want to talk to you about concavity. So what the heck is concavity? What does it mean intuitively? And what's the mathematical definition? And how do you know when you see it? And how can you calculate it when you can't see it? So the idea is there's two kinds of concavity. There's concave down and there's concave up. And so what we got here is we got a picture of a function, and the blue part of the function, that is concave down. And the red part of the function, that part of the function is what we call concave up. And then it happens, there's that place where it changed. There's a place where we changed, where the blue part of the graph changed into the red part of the graph, where the function changed from concave down to concave up. And places where that happens are called inflection points. That's not really important right now, but it's something you'll need to know eventually. So how do you recognize, like, how do I know this part of the function is concave down? And how do I know this part of the function is concave up? So the way I think about it is, I think about it as like frowning and smiling. Like if I just look at the blue part of the graph, that looks like part of a frowny face. If I imagine the, let's see here. If I imagine, the eyes here and the nose there, this is a face that's frowning. So concave down, to me, the way I think about it is it looks like the graph of the function is frowning. Whereas let's contrast that with the concave up part. So the concave up part, actually, let's get rid of that inflection point. I don't think I want it anymore. So let's look at the concave up part of the graph. That looks like part of a happy face. Like if I imagine the eyes and the nose, that's a very happy function right there. So let's see, let me make eyeballs a little bit better. There we go. There we go. All right, that is a very happy function right there. So concave up kind of looks like a smiley face, and concave down looks kind of like a frowny face. But of course, that is definitely not mathematically rigorous, talking about smiley faces and frowny faces. So what we want to do now is understand, okay, what is the mathematical definition of what does it mean to be concave down mathematically, and what does it mean to be concave up mathematically? So like a lot of things in life, we understand this through calculus. And so when I think about calculus, what I think about is tangent lines. So I'm gonna draw a tangent line to this function. And there it is. Okay, yeah, there you go. So I picked some point on the function. So there's some point right there. And this green line is the slope of this green line is the tangent line. Oh, actually, you know what? I forgot something. I probably should write a script before I start recording these, but I guess I haven't gotten to that point yet. Let me talk, before we talk about the mathematical definition, let me talk about a common misconception about concavity. So notice that concavity is not the same as increasing and decreasing. Like on this blue part of the graph is concave down, but part of the graph is increasing. This part of the function is increasing. but this part of the function is decreasing, but it's still all concave down. So a lot of students want to try to make things simple by thinking about concavity as the same as increasing or decreasing, but that's not right. Concavity it's more complicated than that. So concavity is not the same as increasing and decreasing. And same thing like here on this red part. It's always this entire red part is concave up, but you can clearly see that on part of that graph, on this part, the function is decreasing, but on this part, the function is increasing. So again, concavity is not the same as increasing and decreasing. Now it will get confusing because when we give the mathematical definition of concavity, we are going to use the words increasing and decreasing, but we're going to be using them in a very precise manner. So it's not what we usually think about when we think about increasing and decreasing. So make sure that you stay really focused on that because it is a potentially very confusing thing. Okay, so mathematical definition of concavity. So I'm going to draw a tangent line. So here's a tangent line, and I can find the slope. I can find that tangent line has some slope. Where is, oh, wait, here we go. That tangent line has some slope and I'm having the computer calculate it. So this is a very steep line. It has a very large positive slope. Okay, so now what I want you to note, I want you to pay attention to this slope number as I move the point of tangency to the right. So I'm going to start moving this point along the curve, and I'm always moving in the positive direction. So I'm going to move this point along the curve in the positive x direction, and notice what happens to this slope. All right, let's go ahead and try that. Okay, so what did you notice? I hope what you noticed was that this slope is going down. This number is the slope of that tangent line. That number seems to be going down. So when we're on the blue part of the graph, as the x coordinate moves to the right, the slope of the tangent line is going down. And let's see if that continues when we move over the hump. Okay, so, well, maybe let's go a little bit more. Okay, so now what's happening when we get over the hump? So what's happening when we get over the hump, well, is now the slope of the tangent line is negative. But notice as I continue to move to the right, to move to the right, the slope is getting more negative. And if a number gets more negative, that means it's decreasing. Right? If we went from like -18 to -28, that is a decrease. So what's happening is it's the same phenomenon is still happening. As we move to the right on this blue part of the graph, the slope is decreasing. So the slope is a number, and that slope number is decreasing. So we'll keep going for a little bit. And so you can see that as I'm moving along the blue part, that slope is still decreasing. Okay, now we're at the inflection point. So now we're going to start, now I want you to stay focused on this number, but now we've moved on to the red part of the graph. And now notice what's going to happen to this number as we move to the right. Okay, so I hope you saw that. As we move to the right, the slope got less negative. Like we started off at negative 36, and when we moved a little bit to the right, we now have a less negative number. And less negative, that would be an increase, right? Because if a number gets less negative, it's increasing. So what's happening is I move to the right, the slope now is increasing. This number that represents the slope of the tangent line, that number is increasing. And if I keep going over the hump here, we can see it's still increasing. But now it's a positive number. So now the slope of the tangent line is a positive number, but as we move to the right, it's still increasing. So that is the mathematical definition of concavity. Let me write it down here on the screen so that we've got it. So concave down means that the slope is decreasing. I didn't say increasing. I'm going to write it down. Maybe I'll just shut up and I'll write the right thing. Okay. Concave down means the slope is decreasing, and concave up means the slope is increasing. Okay, so see, this is the confusing thing I was talking about. Notice I said we were going to use the word increasing and decreasing when we define concavity, but we're going to use it in a very specific way. That is the key thing you want to pay attention to here is the slope. The slope. It's not I'm not saying that when I talk about being concave down, I am not saying that the function is decreasing. I'm saying the slope is decreasing. And you can't really see the slope in the picture. I mean, unless you draw these tangent lines like we did. But most of the time, you can't really see the slope from the picture. And so don't make that mistake. When I say concave down, I say the slope is decreasing. So the slope, the slope might be a positive number, like it is right here. Right here, the slope is a big positive number. Or the slope could be negative. Right here, the slope is a negative number. So it's not about whether the slope is positive or negative. It's not about whether the function, the graph, whether the graph is increasing or decreasing. It's about how is the slope changing. So is the slope decreasing or is the slope increasing? So that's how concavity works.